Hello everyone, welcome to a lecture on section 4.2, which is solving some basic algebraic equations that involve addition and subtraction. Okay, so first thing I want to do is define what an equation is. So an equation is a mathematical statement that two expressions are equal. So examples of an equation may be something like this, right? If I have, x plus 5 is equal to 2x minus 3, right? That would be an example of an equation. It's saying an expression on the left-hand side equals an expression, algebraic expression on the right-hand side. So really the thing that makes it an equation as opposed to just an expression is the equals, right? This is what makes it an equation, the equals symbol. Okay, and there's many others. I mean, something like, we'll look at equations in this section that look like this. Maybe x minus 3 equals 5, right? A number by itself is also an algebraic expression. So 5 by itself on the right-hand side is fine. Okay, and we'll learn how to solve these equations for the unknown variable. So that's really the main gist of this part of the lecture. All right, so before we talk about actually how to solve these equations for the variable, let's look a little bit at translating sentences to equations. It's similar to translating phrases to expressions, but now we actually want to translate to an equation, right, where we have the equals. So let's look a little bit at that. So translating sentences to equations. Okay, so often when you're asked to solve applied problems, you're going to have to do this translation first before you solve for the unknown variable. So, for example, let's say I give you a sentence like this. X minus 7 is 29. All we want to do is write the corresponding equation, okay? So x is our variable, start with x. Minus means to subtract, right? 7. And then the is here represents equals, right? Is means equals. So the is here, this is going to be, you can interpret that as equals, and then it equals 29. Okay, so that would be the equation, and again, we'll talk about how to solve that in a few minutes. Let's do a few more of these. Let's say I want to translate this sentence to an equation. 8/3 increased by a number yields 13/3. So 8/3 increased by a number yields 13/3. So notice here that our unknown is this number, right? A number. You can give it any name you want. Let's call it maybe y. So we'll call the unknown variable y. So now we have to translate this. So 8/3 increased by y means added, right? So I'm going to do 8/3 plus, increased by means addition, y. And then yields, again, is another name for equals, right? Equals 13/3. So that would be the equation. How about this? 1.5 less than a number is equal to 7.25. Okay, so again, we have to come up with a name for our unknown, which we're calling a number here. Let's just maybe use x. People typically use x, but you can really use whatever name you want, whatever letter you want to represent that unknown number. So remember when we have 1.5 less than a number, we have to write that as x minus 1.5. Right? So something less than something else means the second thing minus the first thing. Is equal to obviously means equals, and then this would be 7.25. All right, let's do one more, and then we'll talk about how to solve these. Let's say I have r decreased by 5.1 equals 6.4. Okay, so decrease by means to subtract, right? So this is really, we can interpret this as r minus 5.1 equals 6.4. So that would be the corresponding equation. Okay, so how do I solve these equations? So solving equations. Well, the goal is to isolate the variable, to get the variable on one side by itself. Typically the left-hand side, but it really doesn't matter. So let me write that. So the goal is to isolate the variable. Because if we have something, like, let's say this equation was x minus 3 equals 5. And let's say I do some operations to that, and I get it to look like an equivalent equation, which says x is equal to 8. Okay, these are equivalent because if I substitute in 8 for x, they both have the same solution, right? So these are equivalent equations. And notice that this one is much easier to see the answer, right? If I plug in 8, then it tells me that 8 equals 8. That's true. So x must be equal to 8. In fact, the way it's written right there, we can just read off the value, right? Since the x is isolated, we can read off that value. So x equals 8. Really what you're doing is you're plugging in 8 and showing that it's true. Okay, so if we can isolate the variable, then it's easy to read off the answer. Okay, so the whole goal is to isolate the variable, right? To come up with an equivalent equation where the variable is isolated. So let me note that these are equivalent. Okay, so how do we do that? How do we isolate the variable? Well, it turns out that we can add or subtract a constant from both sides of the equation as long as we do it to both sides of the equation. So if I have an equation I want to solve, say x plus 19 is equal to 21. I want to solve that for x, right? I have 19 added to x. So in some sense, I want to undo, right? I want to do the addition of the 19. Well, how do you undo an addition? You basically subtract. So what we would do is we would subtract 19, okay, from the left-hand side. That'll undo the addition there. But whatever I do on one side of the equation, I have to do on the other side. So I also have to subtract 19 on the right-hand side. So then this becomes x plus 0. Remember, 19 plus a negative 19 is 0, or 19 minus 19 is 0. And this is equal to 21 minus 19, which is 2. And of course, we know that x plus 0 is just x. So now we have an equivalent equation, except we've isolated the x now, and I can read off the value, right? The answer is going to be x is equal to 2. Okay, so let me write let me write down what we did in words. So since 19 is added to x, we want to undo that operation, basically. So we want to undo the addition by subtracting. $19. But whatever we do to one side, we must do to the other side. So whatever operation we do to one side, we have to do the same thing to the other side. So notice here, in order to isolate the x, I had to subtract 19 on the left-hand side, but I also must subtract 19 on the right-hand side, right? And then I still have an equivalent equation, and now that the x is isolated, I can just read off my answer. X is equal to 2. Okay, and with practice, you'll get very good at doing these. So here's another example. Let's say I want to solve c minus 0.7 is equal to 6. Okay, so since I have 0.7 subtracted from c, to undo that subtraction, I can add, right? I can add 0.7, but whatever I do to one side, I have to do to the other side as well. So on the left-hand side, I'm going to get c plus 0, which is c. And the right-hand side, I'm going to get 6 plus, you can do the work over here if you want, 6 plus 0.7, which is going to be 6.7. And now that my variable is isolated, right, by itself, I can read off the answer, c must be 6.7, right? If I substitute it back in 6.7, that would be a true statement. So c must be 6.7. So that would be the answer. Okay, what if I'm asked to solve t plus 1.5 equals 5? Okay, so to isolate the t, to get t by itself, since 1.5 is added to t, I need to undo that by subtracting it, right? So I'm going to subtract 1.5, but whatever I do to one side, I have to do to the other side. So on the left-hand side, I get t, right? T plus 0, which is just t, equals, and here I have to subtract these mixed numbers. So do you remember how to do that? We can line these up vertically. If you want, you can think of this as like 0 halves right now, right? And I can't subtract 0 half minus 1 half. So here's where I need to borrow from the 5 to make that a 4. And then the fraction part is going to become 2 halves, right? Let me write it down underneath so it's cleaner here. So this I'll leave as 5 and 0 halves, but it's going to become 4 and 2 halves minus 1 and 1 half, right? I rewrote the 5 as 4 and 2 halves. Now I can subtract the fraction parts. So 2 halves minus 1 half is 1 half. And then subtract the whole number parts. 4 minus 1 is 3. Right? So t is going to equal 3.5. So that would be my answer. Okay, and notice that you have to remember how to do the operations of addition and subtraction with fractions, mixed numbers. I'll look at one next with decimal numbers, with whole numbers. So all those things that we learned in the previous chapters are very important. Okay, here's another example. Let's say I have, I'm going to solve x minus 3.2 is equal to 5.23. Okay, so I'll write it down again here. since I'm subtracting 3.2 from the variable x, and I want to get rid of the, think of it as negative 3.2, I need to add 3.2 to both sides. Right? That'll make a 0 there. They give me a 0 there. So x plus 0 is just x. So I isolate the x. But whatever I do to one side, I have to do to the other side. You can do your work right here if you want. So then the right-hand side is going to be, this will be 3, 4, and then 8. Right? So it'll be 8.43. The x is isolated now, so that's my answer. X is 8.43. Okay, here, let's do one where we have to translate to an equation first, and then we'll solve the equation. So I'll say translate, then solve. Say we're given 4 less than t equals 1. Okay, so I'm going to translate that into an equation and then solve the equation. So 4 less than t, remember the way you interpret that, it's going to be the variable t minus 4, right? 4 less than t means t minus 4 equals, and then 1. Okay, so really that's typically the hard part, is coming up with the equation. Once you have the equation, we use our general techniques for solving it. So how do I isolate the t? Well, since 4 is being subtracted from t, I want to undo that by adding 4. But whatever I do to one side, I have to do to the other side. So t in this case is going to equal 5, right? And that will be my answer. So t is equal to 5. Okay, let's do a few more of these where we have to translate first. Let's say we're given 15 more than x is 33. Okay, so 15 more than x is x plus 15, or in this case, you could also say 15 plus x. It doesn't matter because it doesn't matter the order in which you add numbers together. But to keep it consistent with the previous one, when I have 4 less than t, it really means t minus 4. So 15 more than x, I'm going to write it as x plus 15. Okay, I'll start with the variable plus 15, even though with addition, it doesn't really matter what order we write those in. Is, so equals, and then 33. Okay, since 15 is, so now I have my equation, right? Now I want to solve it for x. So since 15 is added to the x, to undo that, I can subtract 15, right? I want to get an x plus 0. I want to get a 0 there. But whatever I do to one side, I have to do to the other side. So I have to subtract 15 from the right-hand side. So the left-hand side gives me x, which is what I wanted. The right-hand side, if we subtract, right, we have to borrow. I'm going to get, what, 8 and then 1, so 18. So that's my answer, right? X must equal 18. Okay, let's see. A number minus 5.5 is the same as 2.5. So I want to translate that into an equation and then solve it. So here we're given some freedom, right? We're just told a number. We can call it whatever we want. X, Y, whatever. Actually, let me call it n for a number. Okay, so I'll call it n. So a number minus, so we have n minus 5.5 is the same as, it means just equals, right? And then 2 and 1/2. So that's my equation. How do I solve it? Well, I want to get n by itself on the left-hand side. 5.5 is subtracted from n, so to undo that, I'm going to add 5.5. But whatever I do to one side, I have to do to the other side. So this gives me n, which is what I want on the left-hand side. It's isolated. And the right-hand side, 1/2 plus 1/2 is 1. right? Or you could write as 2 halves if you want. And then 2 plus 5 is 7. But 2 halves is the same as 1, right? So really this is just equal to 8. Let me write that clear here. So that's equal to 8. So 7 and 2 halves is the same as 8, right? You would combine the 2 halves, you could divide that, get a whole number 1, and then combine it with the whole number piece. So n is equal to 8. Okay, here's another one. So in the following diagram, I'll draw this in a second. Angles ABD and CBD are supplementary. That is, the sum of their measures is 180 degrees. And the question here is going to be to find what y, the variable y, what that equals. Find y. So I'll draw a picture next. So here's the picture. This is A. This is B. This is C. And then this is going to be D. Okay, and we're told that angle, so this angle right here, I can write like this. I can write as angle ABD. That equals 109 degrees. And in this angle right here, which is angle, you could either say DBC or CBD, doesn't matter what order. So I'll say DBC. Let's say that's unknown. We'll call that Y for now. So this is angle Y. So I want to find Y. Well, first I have to set up an equation, right? But what other information are they giving us? They're told that those two angles, ABD, and actually let me use the same because they call it CBD in the question. So let me make sure I have the same notation. So this is angle CBD, right? I want to match the same that they have. So we're told that angle ABD and angle CBD are supplementary. That is, the sum of their measures is 180. So if I were to add this angle plus this angle, I have to get 180 degrees. So that allows us to write an equation, right? We could say 109 plus y must equal 180 degrees. Okay, and now that I have that equation, I can solve it for y. Since 109 is added to y, and it doesn't matter what order you do this in, how do I get rid of the 109? I can subtract it, right? And whatever I do to one side, I do to the other side. So on the left-hand side, I'm just going to get 0 plus y, which is y. So I've isolated my y. And then 180 minus 109, if you do that subtraction, you're going to get 71 degrees. So that would be my answer. Y, the angle y is 71 degrees. Okay, and let me finish up this section just by solving a few questions from our My Up in Math homework. Okay, so in this equation, I have v minus 6 is equal to 4. I want to solve it for v, right? So v minus 6 is equal to 4. Well, since 6 is subtracted from v, to undo that, right? When I say undo, I mean I somehow want to get a 0 there. So I have v plus 0 is just v by itself. So to undo that subtraction, I need to add 6, right? But whatever I do to one side, I have to do to the other side. So I'm going to have v plus 0, which is v. And on the right-hand side, I have 4 plus 6, which is 10. So v is equal to 10. And actually, how would you check it to make sure that you're correct? Because you can always check whether a solution is correct or not. You could plug it back in, right? You could take your equation where you have a v, substitute in 10, and check to make sure that this is correct. Well, 10 minus 6, on the left-hand side, I'm getting 4. On the right-hand side, I have 4. It checks. So yes, 10 is the solution, right? So you can always check to make sure you got the correct solution. Okay, and we'll just do a couple more here. So in this example, question 8, I have 10 equals 8 plus y. I want to solve it for y. Again, it doesn't matter that the variable is on the right-hand side. So what's being done on the right-hand side? 8 is being added to y. So to get rid of the 8, to undo that, I need to subtract 8. But whatever I do to one side, I have to do the other side. So 10 minus 8 is 2. And that equals 0 plus y, which is y. And then I'm done. And it doesn't matter which way you write this, right? If these are equal, if those two expressions are equal, I can switch them. I can say this is the same as y equals 2. Okay, it's usually we put the variable on the left-hand side because it's easier to read it. We read left to right. But it really doesn't matter. So what you could have done is initially at the beginning, you could have immediately moved 8 plus y to the left-hand side equals 10 to the right-hand side, and then solve it, and you get exactly the same thing. Okay, question 9. It looks like the same thing, right? We want to solve this equation for z. Actually, it just so happens it's exactly the same thing. How do I get z by itself? How do I isolate the z? Since 8 is added to z, I need to undo that by subtracting 8, right, from both sides. So in this case, z is equal to 13 minus 8, which is 5. So z is equal to 5. And if you want to check it, plug it back in, right? If I substitute 5 back in for the original z, I'm going to have 5 plus 8, which is 13, is equal to 13. So 13 equals 13. That checks, and we know that we have the correct solution. All right, great. So that's it for this section. Next section, I'm going to review and teach you how to solve multiplication and division equations. So basic algebraic equations again, but now involving multiplication and division instead of addition and subtraction. Great, thanks.